In this lecture, I am going to discuss about convolution integral, and then in next lecture, I will discuss about correlation. Convolution or convolution integral is basically a tool through which you can characterize LTI system. LTI system means linear and time invariant system. Means this system has both property, both characteristics. LTI system means this system will be linear and as well as this system will be time invariant. This system has both characteristic, both property. This is the meaning of linear time invariant system. System will be linear as well as time invariant. And if the system will be linear, then it will follow the principle of superposition. Superposition. And if the system will be time invariant, then its characteristics uh, will be or you can say its characteristic will not depend on time. It means if you will shift its excitation by an amount T naught, then its response will also shift by the same amount. This is the meaning of time invariant, which I have discussed in the previous lecture. If this is LTI system and excitation to this system is xt and corresponding to this excitation response is yt, then if you will shift T naught in its input signal, then its output signal will also be shifted by T naught. This is the meaning of time invariant. And linear system means it will follow the principle of superposition. Means it will follow the principle of or you can say the property of additivity, and as well as it follow the principle of homogeneity. So this is the meaning of LTI system. And convolution integral is a tool through which you can characterize the LTI system. So now I am going to discuss about uh, convolution integral. For this, first I will discuss the meaning of unit impulse response. What is the meaning of unit impulse response? Suppose this is LTI system. LTI system is the system uh, has both the characteristics. It will be linear as well as it will be time invariant. If this is LTI system and if excitation of this system is xt and corresponding to this excitation, if its response is yt, its response is yt, then what is the meaning of unit impulse response? Unit impulse response means if xt is equal to delta t, unit impulse signal, then corresponding to this excitation, the response of LTI system will be called impulse response. So this is the simple meaning of unit impulse response. If you will excite LTI system by impulse signal or unit impulse signal, then response corresponding to this signal or this unit impulse signal will be unit impulse response. So unit impulse response is simply the impulse response is defined as the output of an LTI system due to unit impulse input signal at t equal to 0. So this is the meaning of unit impulse response. The simple meaning is if this is LTI system, means this system has both characteristics. It is linear as well as it is time invariant. And if excitation to the system is delta t, excitation to this system is delta t, then response to this excitation, that is yt, will be called unit impulse response. And it is usually written by ht. Similarly, if the signal is discrete, then response corresponding to this discrete signal will also be discrete. So unit impulse response for discrete signal will be Hn. So this is the meaning of unit impulse response. This is the meaning of unit impulse response. Now what is convolution integral? It is very simple to understand. You can easily understand the meaning of convolution integral. What is the meaning of convolution integral? Let us consider this is LTI system. Means this system follow the principle of superposition because it is linear system, and this system characteristics will be independent from time because it is time invariant system. So if in LTI system, if you will give excitation delta t, then response corresponding to this unit impulse excitation will be unit impulse response. This will be ht. Means if xt equal to delta t, then yt will be equal to ht. This is the meaning of unit impulse response. So symbolically you can write delta t arrow ht. It means if excitation is delta t, then response will be unit impulse response, which is written by ht. Now, in previous video, I have discussed about the shifting theorem. You can take this as question 1. Now, there is a shifting property which I have discussed in previous lecture, which is minus infinity, 2 plus infinity, x tau, delta t minus tau, d tau will be equal to xt. I have discussed this shifting property of impulse signal in previous lecture. So just go through that property. Just revise that property. Why this happens? Because this delta t minus t naught is 0 everywhere except t equal to t naught. At t equal to t naught, its magnitude will not be defined. Its magnitude will be infinity. So everywhere this product will be 0. So you can convert this product as minus infinity, 2 plus infinity, and everywhere this product will be 0 except at tau equal to t, where you cannot say about this product. You cannot say anything about this product because at tau equal to t, delta t minus t naught is not defined. That is why this integral can be converted in this form. And you can take xt common outside the integral because it is a constant. So you can write this as minus infinity to plus infinity delta t minus tau d tau. And this represent the area of delta t minus tau d tau in the range minus infinity to plus infinity. And as I have discussed in the previous lecture, this area will be 1. So this become equal to xt. So this is called shifting property of the impulse signal. So you must remember this also. X tau delta t minus tau d tau will be equal to xt. So you must remember these two equations to understand convolution. Now, I am going to define convolution. For LTI system, if the input or excitation will be delta t, then its response will be impulse response, which is written by ht. Now, since it is a time invariant system, this is a time invariant system. So what is the property of time invariant? If you will shift, if you will give shift in input excitation, then its response will also shift by the same amount. So if delta t is excitation and ht is its response, and if this system is time invariant system, then if you will shift input signal by tau, its output or response will also shift by tau. This is due to time invariant property. And since it is linear also, this system is linear also, and linear system will follow the principle of homogeneity, principle of additive property. So homogeneity means if you will multiply excitation by A, then its response will also be multiplied by A. This is the meaning of homogeneity. If you will multiply x tau in excitation, then this x tau will also be multiplied in response. This is due to principle of homogeneity. And what is principle or you can say additive property? Additive property means if you will add the response, if you will add the excitation, its response will also be added. Means if you will integrate, integration means addition. Integrate the uh, excitation from minus infinity to plus infinity, its response will also be added from minus infinity to plus infinity. This is due to the property of additivity. You can write d tau here and d tau here. And now you can see here. Now you can see left hand side, you can see the excitation part and just compare it with the shifting property. What is x tau delta t minus tau d tau? It is xt. So x tau delta t minus tau d tau, you can write left hand side xt from the shifting property. And its response will be minus infinity to plus infinity x tau ht minus tau. This is the response d tau. This is basically yt response. or this integral is termed as convolution. This integral is written as xt convolution ht, which is equal to yt. So this is the definition of convolution integral. Xt convolution, this is the symbol for the convolution. Convolution is represented by this symbol. If xt convolution ht means integral from minus infinity to plus infinity x tau ht minus tau. So for linear time invariant system, so if for linear time invariant system, if excitation will be xt, then its response will be xt convolution ht. xt convolution ht. And xt convolution ht means this will be equal to integral of minus infinity to plus infinity x tau h t minus tau d tau. This is the meaning of convolution. Or you can write this as minus infinity to plus infinity. You can replace tau with some other symbol. You can write x alpha h t minus alpha. But here d tau will be replaced by d alpha. Or you can write, this is the property of integration, minus infinity to plus infinity x beta ht minus beta. All are same thing, and in place of d alpha you will have to write d beta. So this is the meaning of convolution. If the excitation of LTI system will be xt, then its response yt will be xt convolution ht. So this is the application of convolution. If you have idea about ht, then for any excitation you can determine the response if the system is LTI system. So by just using convolution property, just using convolution integral, you can determine the response of LTI system for any excitation. But thing is, you must know about HT. And what is HT? HT is the response of LTI system when excitation is delta T. When you will give excitation delta T in LTI system, then corresponding to that excitation, the response will be HT. So if you know about delta HT, then for any excitation XT, you can determine the response of LTI system, which is YT, and which will be equal to XT convolution HT. So this is the property of convolution integral, and XT convolution HT will be x tau ht minus tau d tau, integral from minus infinity to plus infinity. So this is the meaning of convolution.